In modern area warfare, air-to-air missiles and advanced fighter jets have become pivotal elements of strategic military operations. Nations around the world invest heavily in these technologies to ensure air superiority in combat scenarios. Among the leading platforms in this domain are the American F-35 Lightning II and F-22 Raptor, and the Pakistani-Chinese JF-17 Thunder. These aircraft, equipped with cutting-edge radar, stealth capabilities, and high-performance air-to-air missiles, shape the dynamics of aerial combat like never before. Air-to-air missiles, AMs, are designed to destroy enemy aircraft while in flight. They come in two primary types: short range, within visual range, or WVR, and long range, beyond visual range, or BVR. Short-range missiles like the AIM-9X Sidewinder and China's PL-10 rely on infrared homing systems and are highly maneuverable, intended for dogfights at close quarters. In contrast, long-range missiles like the AIM-120 and ROM and China's PL-15 use active radar guidance and are capable of engaging enemy aircraft from distances exceeding 100 kilometers. The F-35 Lightning II, developed by Lockheed Martin, is one of the most advanced multi-role stealth fighters in the world. Designed to perform air superiority, ground attack, and intelligence missions, the F-35 boasts a highly integrated sensor suite, low observable stealth technology, and the ability to operate in network-centric warfare environments. It carries a range of air-to-air missiles, including the AIM-120D and AIM-9X, internally to maintain its stealth profile. The aircraft's radar, the AN/APG-81 ASA, allows it to detect and track multiple targets at long range, making it a formidable opponent in BVR combat. The F-22 Raptor, another masterpiece by Lockheed Martin, is tailored specifically for air dominance. With unmatched stealth, supercruise capability, and advanced avionics, the F-22 is considered one of the most capable air superiority fighters. It can cruise at supersonic speeds without afterburners and is equipped with a variety of air-to-air missiles, including the AIM-9 and AIM-120 series. The F-22's radar cross-section is extremely low, enabling it to detect and engage enemies before being detected itself. Its agility and thrust vectoring capabilities also give it the significant edge in dogfights. On the other hand, the JF-17 Thunder, jointly developed by Pakistan and China, represents a cost-effective multi-role fighter capable of delivering solid performance in both air-to-air and air-to-ground missions. Though it lacks the stealth characteristics and advanced electronics of the F-35 or F-22, newer variants such as the JF-17 Block III are equipped with ASA radar, modern avionics, and compatibility with advanced Chinese missiles like the PL-10 and PL-15. The PL-15, in particular, is a long-range BVR missile that some analysts believe may surpass the AIM-120D in range. In any modern air combat scenario, the outcome depends on a complex interplay of detection range, missile performance, electronic warfare capability, and pilot skill. For instance, a stealthy aircraft like the F-22 might detect and shoot down a less stealthy opponent like the JF-17 before being seen. However, advancements in missile range and radar systems can narrow that gap. If a JF-17 with PL-15 missiles is guided by ground-based radar or AWACS aircraft, it could theoretically engage even fifth-generation fighters at extended distances. Ultimately, air-to-air combat is no longer purely about speed and maneuverability, it's about who sees whom first, who shoots first, and who hits. The integration of advanced missiles, stealth design, and next-generation electronics defines who wins the air war. As technology continues to evolve, The line between superiority and survivability grows ever thinner, and success increasingly depends on the harmonious integration of missile systems and aircraft capabilities.